All right, so again, we're just going to simplify. So again, when we are simplifying, if we can't simplify it in the form that it's in, then we switch to the other form and see if we can simplify it that way. So for 64 to the 1/2 power, we would want to switch that to be in radical form. So this really means the same thing as saying the square root of 64, which we know is 8. On number 9, looking at that one, so there's actually two ways that we can do this. We can switch to radical form, so square root of 11 times the square root of 11, which would be the square root of 121, and that equals 11. Or, because we have the same base, we can actually apply our exponent rules and add. So 1/2 plus 1/2 is 1, so we would have 11 to the first power as our simplified answer. So you can approach it either way. All right, 10, we have numbers to our rational exponents, so we don't have the same base, so we do need to switch this time. So we have the square root of 3 times the square root of 12, so that means that we can write this as the square root of 36, and the square root of 36 is 6. All right, the next one, we can't simplify the fraction because we have a 4th root and an 8th root, so we are going to need to switch forms. So this would become x to the 3/4 power over x to the 2/8 power. And again, we can simplify that fraction. So this is really x to the 3/4 power over x to the 1/4 power. And then we can use our exponent rules to simplify. So 3/4 minus 1/4 would be x to the 2/4, which we would then simplify to be x to the 1/2. So we could leave it like this, or if you want, you can write it as the square root of x. So either answer would be acceptable. All right, so next one we're dealing with a number, so we're going to want to switch forms. So we are doing the 5th root of 32, and I know that 32 is a perfect fifth, so again, I'm using my list here. So 32 is on my list. 5th root of 32 is 2. So I'm going to choose to write my power on the outside. So now the 5th root of 32 is 2, and then still to the -3. So remember, when we have a negative exponent, that is telling us to move it down to the denominator. So this is really saying 1 over 2 cubed, which would then give us 1 to the 8th power. So that is our final simplified answer. All right, next one. Okay, so we could use our power rules where we distribute this 2/3 to every single thing in our parentheses, or we could change forms. So looking at this, it would be easier to change forms. So we know that we're going to be doing a cubed root, and then because we have the 2 here, that means that we need to square everything. So I'm just going to square everything as I change forms. So -8 squared will become a positive 64 because we're in parentheses. X squared will be x squared. Y cubed squared, so again we're multiplying that, will be y to the 6th. And then z squared will be z to the 4th power. And then now we're just simplifying that like we did in the previous section. So 64 is a perfect cube. So the cubed root of 64 is 4. This power is smaller than 3, so we can't simplify it. 6 divided by 3 is 2, so we'll have a y squared. And then for the z, we're going to split this as z cubed and then z to the 1st power. So again, this number needs to be divisible by our root, and then the other number needs to be smaller. So the cubed root of z cubed is going to be z, so that will come out, and then we'll have that z left. So we'll have the cubed root of x squared z left inside the radical. So this is our final simplified form. So if we keep going, okay, so again, we're just simplifying. So next one, we can't simplify the fraction, so we are going to need to switch forms. And it is okay to simplify numbers if we can. So the numerator, I'm going to write this as x to the 3/2. And then in the denominator, I can actually take the cubed root of 8, so I'm going to do that. So that'll be a 2. And then I'm going to write x as a fractional exponent. So it's going to be x to the 2/3. So again, what that means is I can use my exponent rules to continue to simplify. So we can take 3/2 minus 2/3. So if we do a little bit of side work, so 3/2 minus 2/3, we would need a common denominator. So our common denominator would be 6. So this one we would have 9/6, and that one would become 4/6. So 9 minus 4 would be 5/6. And again, that represents my power. So now I'm going to have x to the 5/6 over 2. And we can't simplify, so this really means the 6th root of x to the 5th, which can't be simplified. So this is going to be the final answer for this problem. All right, looking at the next one. So we can't multiply as is because we have a square root and a 4th root. So I am going to need to switch forms. So we have 3 to the 1/2 times 3 to the 1/4. So again, I have the same base, so I'm allowed to use my exponent rules where I can just add those together. So if we change it to have the same denominator, this is really the same thing as 2/4 to represent 1/2. So when I add, this will be 3 to the 3/4. And then we just simplify. So we're going to change to radical form again. So 4th root of 3 cubed, and we can't take the 4th root of 3, so I'm going to put the power on the inside, and then we just simplify again. So we will have the 4th root of 27, which is what 3 cubed is. So that is our final simplified answer. All right, next one. So then we're just simplifying. So I can take the cubed root of 8, so that is going to be -2. And then we would still have the cubed root of x, quantity squared. So I can just square each piece now. So -2 squared will be 4. And then when I take the cubed root of x squared, again, that really just means that we're taking the cubed root of x times itself. So that would just give us the cubed root of x squared, which we can't simplify. So this would be our final answer. All right, I'm going to continue with the next set of examples in the next video.